Okie doke. Third video on economic growth. So we had the very quick intro, where we said like technology is key, and then we had the basics of the neoclassical growth model, what's the production function, the key assumptions. Remember, what is capital in the neoclassical growth model? Super important to understand. Okay, and now we're going to look at these two special cases, the Solow model and the Ramsey model. And we're going to mostly look at the Solow model, I can say straight away. And we're going to start with the Solow model with constant technology. The Solow model is a version of the neoclassical growth model in which households use a simple rule of thumb to determine their saving rate. Furthermore, the production function is Cobb-Douglas. So, as I hope you all know, the Cobb-Douglas function is a function in which the different inputs are multiplied by each other and they're raised to different powers. Typically, in the Cobb-Douglas, the powers add up to 1, which, by the way, means that we have constant returns. Okay, so that's our Cobb-Douglas production function. And the capital accumulation equation now, we can replace ST by little s, sorry, we can replace IT by little s YT. Okay, so we just save a proportion, little s, of our production. Okay. Let me just check what's coming here. Yeah. Oh, something's gone a bit funny here with the notes, but never mind. Okay. So one really interesting property of the Cobb-Douglas is its elasticity of substitution, or the elasticity of substitution between the inputs in a Cobb-Douglas function, and we're going to look at that now. Okay, as you know, in economics, an elasticity is a sensitivity, and typically we have some kind of demand elasticity is the most common thing, and then it's the sensitivity of demand to the price. It's like the percentage change in quantity given a percentage change in price. Okay, but an elasticity of substitution, okay, is a percentage change in relative quantities given a percentage change in relative prices. And this could be for inputs to utility in some kind of consumption utility function, or it can be inputs in a production function. So if in the production function I've got quantities of two inputs, Q1 and Q2, like labor and capital, and the price of labor, that's the wage, the price of capital, that's called the rental rate of capital. If the price of labor goes up, I'm typically going to use less labor and more capital, right? And the elasticity of substitution captures how big this effect is. And typically we define it so that it turns out positive. Okay, so we'd say minus the percentage change in quantity over the percentage change in price. And I've defined the Q1 and Q2 I've defined as K and L, and the P1 and P2 I've called WK and WL. And we could switch these over, it would be the same. Okay, wouldn't make any difference. Okay, and then I want you to take, and this is another exercise for you guys to do, I want you to take the Cobb-Douglas function set up the profit maximization problem of a representative final good producer, take first order conditions in the input prices, and take first order conditions in the input prices. Eliminate y from these two equations that you obtain and find eta, where eta, as you can see, is the elasticity of substitution. So, what is a representative final good producer? Well, in the neoclassical model, and I should have said this somewhere, we have perfect competition everywhere, perfect markets. Okay, so how many firms should there be for there to be perfect markets? Is one enough? Definitely not. Then we have a monopoly, right? But is 100 enough? Well, maybe. But it's kind of messy to model, you know. Oh, like if one of these 100 firms does something, what happens to the other 99? It's all getting awfully messy. So we kind of assume that there's effectively like infinite firms, but we can treat it as if it's one firm which is a price taker. Okay. And we call that firm the representative firm. So we say, look, there's actually infinite firms, but in the math we treat it as if there's only one, but it's a price taker. We can talk more about what we're really doing there in when we meet. But that's the basic idea of a representative firm. Okay. So the representative firm, it's as if there's only one firm, but it's a price taker. So what does that mean? That firm is making profits, and what are its profits? Its profits are its revenues minus its costs. Okay? And what are the revenues? Revenue is price times quantity, isn't it? And what are the costs? Well, that's also price times quantity, but for the inputs. So it's the wage. One of the prices is the wage, the other one is the price of rental rate of capital, right? And the firm is a price taker. If it was a monopolist, it could start like, oh, I'm not going to hire so many people, and then the wage will go down. And it would have all these dilemmas going on, right? But we're saying, no, this is a representative firm. It's a price taker. It takes the wage, the rental rate of capital, and the price of the final good as given. Okay? So, I want you to set up the profit maximization problem, specifying the equation for the revenue and the two terms for the costs, and take first order conditions in the things that the firm can control, which is how much labor it hires and how much capital it hires. And by the way, typically we set the price of the widget, here I've called this P, we set that PY, if you like, the price of the final good, we normalize that to 1. You can always normalize one price in any model, any economic model. Okay, you're just sort of setting the overall price level in the economy, but you can only ever normalize one, and then that's it. Okay, so hopefully you can all do that, and then hopefully you can then interpret it. Assume the wage rises by 1% relative to the price of capital. What happens to the factor share of labor? Discuss. Okay, I should just explain what is the factor share of labor. The factor share of labor is what firms spend on hiring labor as a fraction of what they spend altogether. That's the share, the factor share of labor. And it turns out, because the firms are making zero profits, what they spend on all their inputs is the same as what they earn from selling their final good. So another expression for the factor share of labor is just WLL over Y. Okay? Right. So that is some basics about the Solow model, and I'm thinking this video has been going on for a while. Yeah, I think I'm going to stop the video there.